Okay, number 10. An amateur rocketry club is holding a competition. There's cloud cover at 1,000 feet. So up here in the sky, there's cloud cover at 1,000 feet. If a rocket is launched with a velocity of 315 feet per second, okay, so that velocity, 315, it goes in place of this V right here. So it's launched from the ground. So that means the starting height right here, H sub 0, also known as S, is 0 because it's starting from the ground. And we are supposed to determine how long, which is time. So how long is the rocket out of sight? So we really need to think about context of the problem or we are going to get totally lost. So we know it is h of t equals negative 16t squared plus 315t plus 0. An upside down parabola, an upside down U, so an opening down parabola, starting height of 0, so it goes like this. Now, obviously there must be some cloud cover, and it must be within the height that the rocket reaches. It's not asking for the maximum height of the rocket, it's asking how long it's out of sight. So we're going to say that this is the cloud cover at 1,000. So right here are the clouds. So that means that the rocket from here to here, this is the path of the rocket, is out of sight because it's in cloud cover. So remember, this is time, this is height. So we need to find, our plan is to find this and this. Those are both t values. We're going to call that t sub 1, so the first time value we want. And we'll call this one t sub 2, so the second time value that we want. So once we find both of those time values, we'll just subtract, and that will tell us how long the rocket is out of sight. Because the rocket is out of sight from here all the way to there, okay? So what is our plan? Well, our plan is simple now that we understand the context, or it should be simple. In y1, you will put the function. Now when we use x's, serve the same purpose. So negative 16x squared plus 315x, and I can leave off that 0. Now in y2, let's think about it. On other problems, we want to know when it hits the ground. This one is not asking that, but when we do, that's when the height is 0. What height do we desire here? We want to investigate when the rocket is at a height of 1,000 feet. So we want in y2 to put 1,000. So we need to go and do this. So let's grab our calculators. In y1 you type negative 16x squared plus 315x, and in y2 you put 1,000. Now, I want us all to hit zoom 6 so that we're on a standard window together. Now you're going to see it thinking. As long as it's moving that up there, it's thinking, and you're going to think you're wrong because you know what? We don't see anything. But let's think about this. We've got a height of 1,000, and we know the rocket goes above that. So these are big numbers that we're dealing with on this problem. So it makes intuitive sense that you won't see it in a viewing window that's going from negative 10 to 10, negative 10 to 10. So we need to adjust our window. So let's see. We know it's going to go above 1,000. So let's go to window, and let's change our Y max to something above 1,000. I'm just going to pick 1,100. You can pick whatever as long as you can see it. So I go to Y max and I'm going to type in 1,100. Now I'm going to hit graph. I hit graph and I see something. I definitely see something. I see part of the parabola, which is good. That's going to be t sub 1 right there. That will give me the first intersection point that I want to find. This is the clouds. This is the cloud cover. This simulates the cloud covers. That's at y equals 1,000 because that's what we told it to do. Now I still want to see the other part of the parabola. So what do we need to change over there? We need to go to window and we need to change our x maximum. It's only at 10 right now. So you just play around with it and change it to something that you think will work. Let's try 30 because it's at 10. So let's try to change our x max to 30. So I change my x max to 30 and then I hit graph. And I hope it works. If not, I go back and adjust. And sure enough, it works. So some of you may go, well, Miss Sharp, I don't see the maximum of the parabola. You don't need it in context of this problem. It didn't ask me for the maximum height. It didn't ask me when it reached the maximum height. It asked me, how long is the rocket out of sight? So now my plan is to find that intersection point and that intersection point, T1, T2, and subtract. Okay, so how do I do that? I go to second, calc. So let's do that. Second calc. What do you think we will choose? Well, probably intersection point. So hit 5. Now here's what it says. It says first curve, da-da-da-da-da. Here's the deal. We've got to find 2 intersection points. So right now, let's just focus on this intersection point. we need to move Blinky Man right there. So I don't see Blinky Man. He's there, but I don't see him. So what I always do to find him is I hit the up arrow. When you do that, something magical happens. I see Blinky. Now I need to move Blinky way over here, right on top of what I'm trying to find. So that's what I did. I moved Blinky way over there, and then I hit enter 3 times. So you want to move Blinky Man to the intersection point that you're trying to find. So that's what I just did. And then you want to hit enter 3 times. Enter, enter, enter. So enter, enter, enter. And then this is what I get. I get that first intersection point is at 3.98, comma 1,000. It better be 1,000 because that's how we made it work. That's what we set it up for. So this t sub 1 is 3.98 seconds, okay? Now we need to do the whole process over to find this process, to find the other intersection point. So second calc 5, I'm going to hit the up arrow so I can see Blinky. And then I'm gonna scroll over until Blinky Man is right on top of the intersection point that I'm trying to find. So now I've got Blinky right here. And then I move Blinky, then I hit enter 3 times. And I got 15.71 this time. So this ordered pair is 15.71, 1,000. So that means t sub 2 is 15.71. So now that means at time 3.98, it goes to the clouds. And then from 3.98 seconds to 15.71 seconds, it's out of sight. So how do we actually answer the question? Determine how long the rocket is out of sight? Well, I will do 15.71 seconds minus the 3.98 seconds, and that will give me 11.73 seconds. So that means that the rocket is out of sight for 11.73 seconds. Period. Box in your answer. Ta-da! I hope you loved it.